Question number 28, another from rotation. So now you get a back-to-back one, and this one is pertaining to moment of inertia. So there is a disk of mass m, radius r, which is disk D1. Disk D2 and D3 are identical to D1, and they are attached in this given way. We need to calculate the moment of inertia of this given arrangement about the axis OO dash. So to do that, first for the D1, that's straightway mr square by 2, and for D3 and D2, which are identically located, that's going to be mr square by 4 plus mr square, that's a shift in parallel axis, multiplied by 2. So that's going to give the moment of inertia. And now let's try to see how much would be the value. You add all, that's going to be 3 mr square. So option number 1 is the correct for this. Time to move to question number 29. The penultimate one, question number 29, again from semiconductor physics, the area which is excluded in JEE advanced syllabus. Now here it's so clear that D1 is forward bias, D2 would be reverse bias. Together it also says that the forward bias resistance is 50 ohm. So since this is reverse bias, this would be open, and this would be simply replaced by a resistance of 50 ohm. We need to calculate the current through 100 ohm. So I think that's quite a simple one. 6 divided by, you see, 100 plus 150 plus 150, that comes out to be 300. So that's the current, and 1 by 50, which means 0.02 ampere. So option number 2 is the correct one for question number 29. Time for the final question, question number 30. The final question from the topic of electromagnetic induction, and it says something like this: a copper wire is wound on a wooden frame whose shape is that of an equilateral triangle. So here is an equilateral triangle, and a copper wire is wound in this given manner. Okay? If the linear dimension of each side of the frame is increased by a factor of 3, keeping the number of turns of the coil per unit length of the frame same. So number of turns per unit length is same. That means when the length increases, the number of turn also increases proportionately. You need to see how does self-inductance change. Now this may be a bit of tricky, but you could see if I call this length as L, L is the length of the side of the triangle. Self-inductance, if you see the formula, mu naught n square area multiplied by length. So that length, in other words, self-inductance would be equals to mu naught n square, the cross-sectional area, into 3 of L, where L is the total length you need to write. So that will become 3L, because small l is the length of a side. So mu naught n square A multiplied by the total length. Now rest all parameters are constant. It just says that the linear part has been increased by 3 times. So yes, the self-inductance increases by a factor of 3, not by a factor of 9. You better be careful on that point. So question number 30 has first option as the correct option. And with this, we end up the discussion of physics JEE Main 2019 conducted on 11th day of January at the evening shift. I hope the one who did and who wrote their paper had a very nice time, and specifically if you are a viewer who is yet to sit for that examination, just try to follow the trend, try to follow the psychology. That's very, very much important. Hope these all discussions were very useful. Thanks for watching. Thank you very much.